This video will show you how to insert images into the geometry sticky and then to use the images to help students discover transformations and the connection between similarity and congruency. So first we're going to get a geometry sticky out, and so I'm going to click, choose my geometry icon. This brings up my geometry sticky. To insert an image in geometry, if you look down here across the bottom, you'll see this A that represents text. You can write text right onto the screen. But if you click the drop down, you'll see this middle one is an image. So I'm going to click this, and this icon comes up, this little sticky here, and it's looking for a picture for you to insert. And so I'm going to click it. It's going to take me to where I might have some pictures. And so we're going to go to these pictures, and I'm going to use a real world image because we're working with students. We want them to have a connection to what we're working with. And I'm going to move this just over so we can see what's happening. And I'm going to hit OK. And so now that image is in my graph. And you'll notice that the image then gets this little template over here where I have defaults. So it's centered at 0, 0. It has no angle. It's straight on, and it's at its original size. I can move the image to the front or the back, but at this point, since it's the only image, it doesn't make a difference. I did want to point out, where's this 0, 0 coming from? In the geometry sticky, if you go up to settings, the 3 dots always mean settings, the axes are turned off in geometry, but you could turn them on. And if I hit OK, you'll see that this is now the center of my picture, and that's where they're saying it's centered at 0, 0. So this image, which is a rectangle, the center of it, the exact center, is right here at 0, 0. I'm going to turn off my axes because I don't want to see them. So we have a bunny, and I'm going to now insert a second image, and it's going to be exactly the same as my first image. So I am going to get another bunny, double click it. So all I'm doing is double clicking it, or you can go down here, down and hit open, and it puts the bunny in here, and I'm going to say OK again. Now notice it doesn't look like anything happened, and that's because I've basically layered them on top of each other, which is what we're trying to do here. We have these layered images, and I'm going to put the second one to the front because it's the one I'm going to be transforming, working with. So right now they're exactly the same. So this is a nice connection for students. Why don't I see the second image? Well, it's exactly the same as the original image. They're on top of each other. They're in the same location. Everything about them is the same. Well, what happens if I change the dimensions of the second bunny? And we've been working with students at this point have worked with proportions and scales. What if I scale the second bunny to be smaller? So let's scale it down to be half the size. So half of 10 is 5, and half the height is also 5. And so now watch what happens when I hit execute or enter, depending. I now get my second image is smaller. It is half the size of the original image. And here's where you can make that nice connection between similarity and your dilation. What did we just do? We shrunk our original image down by half, and we now have the exact same bunny. Everything about this bunny is exactly the same as the original, except it is half. So this large ear from the original in the second bunny is exactly half of the large. So you can talk about those relationships and what similarity mean. Similarity means it's just a different size, but like the angle of the ear is the same as the angle in the original ear. All of that is the same. We have simply shrunk it down. So you can play around with those types of things. You could now make the bunny larger. Let's just make him larger than the original. And what's going to happen here, we're not going to see the original because the second bunny will now be larger and is covering up the original. If we wanted to see the original, we could send the second bunny to the back and the first one to the front. And now we'll see, oh, the second one's in the back, it's larger. So it's sort of that same concept. So I'm going to switch them back. So I'm playing around right now with the width and the height, which are the dimensions, and those are being dilated either larger or smaller. And so you can make that connection with students. Let's change it back to the original so they're exactly the same again. So 10 and 10. And now let's talk about these other numbers here, center, X, and Y. So what if I change those in the second bunny? What will happen? And this is where the nice connection using images, it helps you understand what translations mean or what rotations mean. So we're not going to change the dimensions anymore of the bunny. So the bunnies are exactly the same. Right now, it's a 1-to-1. They are congruent. So my proportions are exactly the same. But let's now change the center of the bunny, the second bunny. Let's move him maybe over, let's make it 3. So watch what happens. So the second bunny is no longer at center 0. It is over 3. What happened to it? It moved to the right. It's the same exact bunny. So these two bunnies are congruent, exactly the same. We didn't change their size. The only thing we changed was their location. We slid the second one to the right. And so now you can talk about what's the difference between similarity. When we changed the size, we had similar bunnies, but not the same size. But now when we change the location, we have exactly the same bunny, just in different locations. So what's that connection between similarity and congruency? And you can go back and so let's think about this. We added a 3 to the center and a 2, and what happened to the bunny? Moved to the right, positive, and up 2. So then you can start making those connections between transformations and positive and negative movements. So this is the horizontal and vertical shifts. You could put your axes back on, and you could challenge students, can you move this second bunny over here into this quadrant? What would you have to do? And hopefully after they've explored, that means they would have to go to the left and go down. So let's see if we can just do it here. So if I go to the left 2 and I go down, let's make it -3. He's almost there. I probably needed to go over to the left a little bit more, right? So all of these things, we have the exact same bunny. These are congruent bunnies because we didn't change the dimensions, the size. We didn't dilate by scale factor. We kept them the same, but they are in different locations, so they're congruent bunnies. Let's put the bunny back to its beginning, and I'll just go over the last thing on the image template here. So now we have them back exactly the same, one right on top of each other, proportion of 1. Let's see what happens if I change the angle of the second bunny. So let's make the angle of the second bunny be 45. What happens? So here was the second bunny. Here's the original bunny. They're still exactly the same. They're still congruent, but the second bunny, the one that's on top, has turned, right? So the angle turns my image. So now you can talk about turns and rotations, and then you could combine them. Is there a way for you to turn them upside down? What would you have to do? What if you want to turn them to the left? What if you want to turn them to the right? But talking about rotations, and rotations are not changing the bunny, they're changing how the bunny is oriented. So using real world images where they can actually see the similarities and the congruency, if you just change the location or you change the size, which is your dilation, you can help students understand what transformations are doing, and they're doing it with something that's fun to look at and that they can connect to. So inserting images and layering images and then using the image template to control the movement helps students to understand transformations in a very simple but connected way to their prior knowledge of proportions and similarity and congruency.